First of all, for me, it's a great pleasure to say here, by the first time after 3 years, that we have been suffering from pandemic, and I think we need to have this type of front-to-front meetings. Today, on this ceremony, what we want, we are very pleased to all of you that not only because you joined, but first of all, because what you did in favor of science and the awards that you will receive today is just a small recognition of the Academy of all your merits. Of course, on this type of recognition, I have to point it out, some are already members and fellows of our Academy, the others are not. But once you receive the award, automatically you became a member of the Academy, and so you have to follow the rules of our Academy. And it is also a great pleasure. So what we will try to do today is, of course, we used Zoom in the past, and we heard the speech of our distinguished personalities that received the prizes. Today, what we will do for the ones that have already spoken, so it was in 2020, we will make the award, the lauda, and the lauda will be absolutely reduced, and it will be the head of division that named so outstanding personalities to receive the prizes. Namely, we will start by Leonardo da Vinci, that is the great prize that the Academy has, and then we have the Blaise Pascal. That also is a competition, and we want to keep this as a competition between divisions. We are 8 divisions, and per year we gave only 4 prizes, which means that we want really to select the best out of the best. And this is also fantastic, I have to say. We are very glad also for all during these 3 years, our distinguished personalities from our Academy, they reached outstanding positions. Of course, I will start by my wife, that now is Minister of Science and Technology. And also she was considered one of the 20 inventors of all times. It disappears 2 weeks ago together with Nikola Tesla. So it was, Ericsson did a commitment, try to see what was the people from the past. And the most outstanding prizes that we receive is from Earth Environment and Earth Division, the Gulbenkian Prize, John Potter. It was really fantastic because John Potter is the head of the division now, and he has been involved from the beginning from EPCC, and they got the outstanding prize. The Gulbenkian Prize is similar to a Nobel Prize. The value is even higher because it's 1 million euros, and 12 members of the Health Division, at least, has been involved from the beginning on pro bonus, which EPCC is just like that. And so they take care, and they have been really target the problems of climate change. This was 2 weeks ago, and I'm very proud with what you did, John, not for the Academy, for the Earth, because we don't have second planet, we have not planet B, and thank you very much for all these achievements. And those are the things that we aim to go further and to go even better and better what we can do. And of course, this year was not the case, but in the last 2 years, the Nobel laureate have been also members of our Academy, starting by the physics and also the chemistry, so we have our distinguished heads of the divisions. So this makes us proud, and today we will have also a fellow that became a fellow of us, which is the president of the European Research Council. And also we hope to get more so outstanding personalities here, and also we will have among us this afternoon Graça Carvalho, that she was who designed the European Institute of Technology, and she has been a very preeminent deputy, and also with strong commitments in the definition of science policies in Europe. And at the end, in the conclusions, we will have the Vice President of the European Parliament also because this is something very important, is we must make science not isolated in an island, but we have to communicate, and we have to have the stakeholders that really think that science is the best thing. And moreover, we will be in G7. Unfortunately, Daniel cannot go. And this will be a very nice experience for all of us to see there and to see how we really can interact with the most powerful countries in the world. So saying so, I open the ceremony, and I give the floor now to my colleague, Professor Steven De Vijter, to introduce Professor Klaus Mullen from Max Planck Institute.
Good morning. I'm Steven De Vijter from KU Leuven in Belgium, and I'm here on behalf of Federico Rosé. Professor Klaus Mullen studied chemistry at the University of Cologne and obtained a PhD degree in chemistry at the University of Basel. He held professorships at the University of Cologne and the University of Mainz, and was scientific member of the Max Planck Society and director at the Max Planck Institute for Polymer Research in Mainz. He is fellow of several academies. His fundamental approach of a bottom-up based synthesis towards highly defined functional carbon nanomaterials has been awarded by an impressive list of prestigious prizes, including the 2019 Carl Ziegel Award of the German Chemical Society and the 2019 Continuous Medal of the German National Academy of Sciences, Leopoldina. He received in total 8 honorary degrees. He has served as president of the German Chemical Society and of the German Association for the Advancement of Science and Medicine. Professor Mullen's work has been devoted to opening new chemical frontiers at the nanoscale to tackle technologically relevant societal problems. His groundbreaking contributions have led to the development of functional carbon nanomaterials with molecular precision. He is the pioneer in the synthesis of nanographene and graphene nanoribbons. These and other functional structurally perfect materials and polymers have many applications, ranging from single molecule labeling, manipulation and detection, to organic electronic devices, sensors, and catalysis. The philosophy of his research is based on the combination of organic and polymer chemistry to form materials in a controlled way, and with molecular and atomic precision, and thus featuring well-defined and unique physicochemical properties. His seminal contributions have advanced our fundamental understanding of chemistry at the nanoscale, as well as our ability to control molecular processes. His groundbreaking work on nanoscale controlled functional carbon materials, in particular based on graphenes and their molecularly defined cutouts, resulted in strong, mutually stimulating and efficient cooperation with leading chemists, physicists, and engineers in nano and material sciences. Similarly, the spectacular rise of single-molecule spectroscopy and nanoscopy was tightly bound to the sophisticated synthesis of high-performance chromophores by his group. Throughout his scientific career, he has been a strong believer in the power of interdisciplinarity, working with researchers with diverse backgrounds and tackling research questions involving chemistry, physics, and biology. The technological relevance of his activity, being key to the success of the strong interactions with industry, is reflected in having filed over 70 patents. He is the author of numerous pioneering works which have opened new frontiers in polymer chemistry, molecular electronics, renewable energy, and more generally, material sciences. Being the co-author of over 2,000 articles in leading chemistry and multidisciplinary journals, he is one of the most prolific chemists and the most cited German chemist. All in all, there is no scientist or research group in the world pursuing a more comprehensive program in nanochemistry. The strength of Professor Mullen's research has been the use of innovative synthetic routes to develop novel chemical systems as building blocks for the bottom-up fabrication of multifunctional materials. This unique approach gives unprecedented control to reproducibly fabricate nanomaterials with precisely controlled features. Therefore, the Leonardo da Vinci Award is then awarded to Professor Klaus Mullen for outstanding lifelong achievement. Congratulations, Professor Klaus Mullen.
This is the award that you deserve, and we are very honored to have you here. This is the diploma.
I'm very proud I can give you a diploma.
Slowly that they can take the photograph. Yes. Otherwise we need to do it again.
Thank you very much.
Congratulations, Klaus. Congratulations.
That's the second. Thank you.
Good morning, everyone. I was just informed that I'm supposed to say a few words. You could say an award of 2020 delivered in 2022. This guy is history. What I would respond is let us quickly get it done before the next corona wave sets in. But you may want to know what we stand for. You heard these words of Stephen. I wished I were really up to it. I didn't know whom he was talking about, but I can offer you two explanations of what we do as materials chemists. And I like to quote from true authorities. One is Madonna. We live in a material world. More seriously, this is Eiji Kobayashi, former head of research of Panasonic. Those who control materials control technologies. But think about it, when we talk about materials, someone must make them. And I think it is a good idea that those make them who know how to do it. And this are us. Thank you very much for this great honor.
So, ladies and gentlemen, dear colleagues, so I am Alain Tressou, the Vice President of the Eurasc Academy, and it's for me a pleasure and honor to introduce those colleagues who got the Blaise Pascal Medal in 2020, and who have been waiting 2 years to come in front of us because of health reasons, of course. And so the first presentation will be for the Blaise Pascal Medal obtained in mathematics by Professor Albert Cohen from Sorbonne University. And the presentation will be done by Professor José Carrillo, head of Mathematics Division. So please.
Ladies and gentlemen, it's for me a pleasure to award the Blaise Pascal Medal in Mathematics 2020 to Albert Cohen. Let me say a few words about his work. Albert Cohen is a full professor at the Laboratório Jacques-Louis Lyon, Sorbonne Universitaire nowadays, and having done his PhD with Yves Meyer, Abel Prize in 2017, his early research works were concerned with the development of the theory of wavelet basis in relation with algorithms used in signal and image processing. In fact, Professor Cohen met Professor Dovechis in 1990 when she was still working at the Bell Labs, and they published together more than 15 outstanding papers related to the development of wavelets. A significant achievement was the theoretical explanation of the success of wavelets-based compression algorithms for images. On the other hand, Professor Cohen, together with Professor Dovechis and Professor Fauveau, introduced by orthogonal wavelet bases, which are used in the state-of-the-art of image compression standard, like the JPEG 2000, widely used nowadays. Since 1998, his research is oriented in various applicative directions, with the common denominator of the theoretical foundations in nonlinear approximation theory and harmonic analysis. And in particular, it has led to development and analysis of adaptive and sparsity-based numerical methods in various applications, such as data compression, statistical estimation, discretization of partial differential equations. On this program, Professor Cohen was also awarded an ERC Advanced Grant in 2014, and his current research is in particular concerned with problems that involve a very large number of variables in the so-called curves of dimensionality, meaning that computational complexity increases exponentially in the with the variable of the dimension. And such problems are ubiquitous in an increasing number of applications, such as statistical or active learning theory, parametric and stochastic partial differential equations, parameter optimization, and many others, with a great important application in the industrial world. Finally, the high-level research that has been internationally recognized with many prizes, such as the Popov Prize in Approximation Theory, the Blaise Pascal Prize of the Société Mathématique Appliquée Industrielle from France, and also he was a speaker at the International Congress of Mathematicians in 2002. So, Albert, it's a pleasure to award you the prize.
Ladies and gentlemen, it's a pleasure to be here. I had not planned to speak. Okay, I must say, there must be something between me and Blaise Pascal, because I also received a similar named award in France. I'm looking forward to the next one. Okay, mathematics, maybe as opposed to other more experimental discipline represented here, as this reputation of people working a little bit in an ivory tower. And I want to stress how important it is as a mathematician to have interaction, human interaction, which has been deeply missed during these COVID periods. So I want to dedicate this award to my mentors, my colleagues, and my students. Thank you.
Thank you so much, and congratulations, Professor Cohen. And now we will move to the second Blaise Pascal Medal 2020 in physics. Will be attributed to Sir Tejinder Singh Virden from Imperial College, London. And the presentation of Sir Tejinder will be done by Paul Lecoq, the head of the physics division. Paul.
Okay, good morning, everybody. And Sir Tejinder Virden is a British particle physicist from Imperial College, as was said by Alain, having spent a large fraction of his brilliant scientific career at CERN in Geneva. Back to the mid-80s, 1980s, when he joined the UA1 experiment at CERN, proton collider facility, developed and led by Nobel laureate Carlo Rubbia, who is, by the way, also a member of our academy. Jim Verdi has proposed a very clever way of reading out scintillator plates in a new uranium scintillator sampling calorimeter. To make a long and brilliant career very short, I jump immediately to the major and lasting impact of Jim Verdi in modern collider physics, which came with a Large Hadron Collider at CERN, the LHC, where I had the immense privilege to work with him. He was very central in all phases of these experiments. One of the two major experiments at the Large Hadron Collider, from its very early conception to the realization of the detector, from early physics potential studies to the final analysis leading to the discovery of the Higgs boson in 2012. And this very exceptional career is extending now into a visionary CMS upgrade project he pilots for the future high luminosity Large Hadron Collider running. Jim Verdi is one of the leading scientists on the CMS experiment now for 3 decades, a truly remarkable achievement. This exceptional scientific career is evidenced by an impressive number of prestigious honors of prize, like the Knight Bachelor Queen's Birthday honors in the UK and the very famous Panofsky Prize in experimental particle physics from the American Physical Society in the USA, just to cite 2 of them among a long list. Dear Jim, allow me to call you Jim, because we are a good friend. It is my great pleasure and immense honor to present you the 2020 Blaise Pascal Medal in Physics.
It's a pleasure to be here this morning. First, I'd like to thank the European Academy of Sciences for the award of the 2020 Blaise Pascal Medal, and also to Paul for his very kind words. As he mentioned 10 years ago, the CMS and the ATLAS experiments at the Large Hadron Collider in Geneva discovered the Higgs boson. The Higgs boson is the quantum of a field that pervades the universe, which is here as well today. And massless fundamental particles acquire mass by interacting with this field. For example, the electron acquires its mass by interacting with this field. This allows atoms to form and life to exist, in a sense, and gives the universe substance. So it is very fundamental to have discovered this particle. Now, to enable this discovery required the talents and the resources of about 8,000 scientists in the 2 experiments from about 70 countries around the world. So it did require a lot of effort. And the international collaboration that was set up and has functioned very well had to face many challenges which are related to the scientific challenges, which is the first one. Technological challenges, I think Paul has mentioned a few of those. And then also the sociological challenges, as well as diplomatic challenges. So I think such experiments, such collaborations deserve a round of applause as well. Thank you.
Now we will move to the presentation of the Blaise Pascal Medal 2020 in chemistry. This medal has been attributed to Professor Manfred Reitz from Max Planck Institute. So unfortunately, Professor Reyes is not here, and there will be a video, or a Zoom. Okay, it will be a Zoom. Maybe the head of the department of the division of chemistry, Pierre Bronstein, would like to say some word before, and then the video will run. Pierre?
Good morning, everyone. It's great to see you in person after all these years of frustration. Good morning, Manfred, if you can hear us. He was full professor of organic chemistry in Marburg, then became director of the Max Planck Institute for Kohlenforschung in Mülheim as successor of Günther Wilke. It was in this institute, founded in 1912, that the Fischer-Tropsch process for transforming coal into gasoline or diesel fuel was invented, and that Carl Ziegler carried out his work on the polymerization of ethylene and propylene, which earned him to share the Nobel Prize in Chemistry in 1963 with the Italian chemist Natta, the Ziegler-Natta process. Many major discoveries have been made there and have maintained this institute at the highest level in the world. This is to say that directing it is an honor that is reserved only for an elite. After his formal retirement as director in 2011, Manfred Reetz became the first Hans Meerwein Research Professor in the chemistry department of Marburg University. In 2019, he returned to Mülheim at the Max Planck Institute and also accepted the position of deputy director of the Reetz Laboratory in China at the Tianjin Institute of Industrial Biocatalysis of the Chinese Academy of Sciences. As an organic chemist, Manfred Reetz focused first on the development of chemo and stereoselective organometallic reagents and catalysts. He then turned to biocatalysis, first inventing novel salt gel-based enzyme immobilization techniques. The period 1994-1998 saw the birth of a fundamentally new concept, the directed evolution in the test tube of stereoselective enzymes as catalysts in organic chemistry and biotechnology, which complements transitional catalysts and organocatalysis. At the time, protein engineers were focusing on enzyme stability, such as Francis Arnold, Nobel laureate for chemistry in 2018, and you will hear about them tomorrow. But believing that enantio and regioselectivity could be controlled by directed evolution was a scientific adventure. In his pioneering work and endeavor, Reetz used gene mutagenesis techniques to generate large libraries of potentially enantioselective enzyme mutants, and high-throughput techniques allowed him to screen thousands of mutants. Directed evolution of artificial and metalloenzymes was also proposed by Reetz in the year 2000-2002 and first implemented in 2006, and to date likewise constitute a flourishing research area. His pioneering studies in directed evolution were so impressive that around 2002-2004, other groups joined efforts. Today, the concept is routinely used by numerous academic and industrial groups worldwide. It provides a never-ending source of catalysts for selective transformations in organic chemistry and biotechnology, and their ecologically and economically viable conditions. As one of many examples from the Reetz group, the regio and stereoselective oxidation hydroxylation of steroids led to pharmaceutically important products. More recently, used machine learning as a form of artificial intelligence and constructed solid-phase mutant DNA library on silicon chips. He has been a major driver in the exciting field of directed evolution, and his numerous publications in the most prestigious journals are highly influential. Manfred Reetz is a member of the German National Academy of Sciences Leopoldina, the Royal Netherlands Academy of Arts and Sciences, honorary professor at the Shanghai Institute for Organic Chemistry, a honorary member of the Israeli Chemical Society. He has received numerous prestigious awards, such as the Leibniz Prize of the German Science Foundation, the Carl Ziegler Prize, the Prelog Medal from Switzerland, Arthur Kopp Award from the US, and is Distinguished Scientist Award from the Chinese Academy of Sciences. Manfred, it would have been a real pleasure to congratulate you in person today. We will do it via video, but we are very proud to count you and among the Blaise Pascal laureate of the chemistry division. Thank you, congratulations.
Thank you very much, Pierre. These are very, very kind words that you spoke, and very comprehensively also, so thank you very, very much. I'm very sorry that I was not able to come to Brussels today. Therefore, it's all the more important that I say a few words of thanks. Of course, my gratitude goes to the Academy and to the Honorable Professor Martins. It is something special to receive this award. Blaise Pascal was not only a fantastic mathematician, but also a theologian, a philosopher, a true French scholar, and therefore a true European scholar. I also want to take this opportunity to thank my co-workers who joined me in this adventure. Pierre just mentioned that it was a very risky endeavor because there was no precedence at all. And the consideration of trying to manipulate the stereo and regioselectivity of enzymes was a daunting task at the time. So I'm very grateful to all of my past and present co-workers who joined this adventure. Some of them came from France. And finally, I want to wish all of you who have assembled in Brussels to have an interesting and exciting day. Merci beaucoup.
Thank you very much again.
Wait, we will take an image giving you the certificate and the medal. Just keep it. Can you show?
Yeah. Just show the medal to him. Manfred, can you see the medal?
Yes, I can see it.
Excellent. It's yours, incidentally.
Okay, thank you. Okay.
Thank you again. My wife just gave me a kiss.
And we give the heart to you.
Thank you very much, Professor Reds, for this very vivid presentation. And now we will speak about Blaise Pascal Medal given in the Engineering Division in 2020 to Professor John Katsikadelis from the National Technical University in Athens. Unfortunately, Professor Katsikadelis could not attend the meeting, and it will be Professor Alberto Carpinteri, head of Engineering Division, who will present his achievement. Alberto?
Good morning to everybody. I'm here to present Professor John Katsikadelis, who won the prize in 2020. He is a former professor of the National Technical University of Athens. And he's belonging to different academies. And he's a department in civil engineering, a school of civil engineering at the Athens University. He presents a wide spectrum of research topics, and he published in very well-known journals of our field. He was the director of the Hellenic Society of Earthquake Engineering, but who also took a position of responsibility in the European Union. He was, in fact, the director of the engineering earthquake protection organization in Greece, but also in Europe. He also took a position in the field of civil protection in general and earthquake hazard in the European Union. He published 20 books. Some of them are published by Elsevier and also translated in different languages, precisely in Russian, Portuguese, and Poland. Professor Katsikadelis belongs to different academies, and he was the editor-in-chief of 7 different journals, international journals. I think that the width and depth of his research contributions are really very significant and diversified. This is also my sector, is structural engineering. He was a specialist, especially in computational mechanics and the boundary elements analysis. I think that he can be considered a first-order ranked scientist worldwide. Thank you very much. Change my glasses.
You can go just to simulate. So, Professor?
Yes, a moment, please.
Again, my congratulations to Professor Katsikadelis. And the next Blaise Pascal medal attributed in 2020 in material science was given to Professor Ian McCulloch from the Imperial College London. So he could not join us for the moment, and there will be video, I think. No video, okay. And so I asked Professor Stephen De Feiter to come to present the work of Ian McCulloch. Please, Stephen.
So, good morning. Professor McCulloch is a professor of polymer chemistry in the Department of Chemistry at the University of Oxford, UK. He also holds a joint position as professor of polymer materials within the program of chemical sciences at King Abdullah University of Science and Technology, housed in Saudi Arabia, and serves as director of the Coast Solar Center. Professor McCulloch is also a visiting professor in the Department of Chemistry at Imperial College London. He began his career after graduating with a PhD in polymer chemistry from the University of Strathclyde in the UK, at Hoechst Calanese Corporation in New Jersey, where he designed, developed, and commercialized functional polymers for a range of optical, electronic, and drug delivery applications. He then moved to ISP Corporation in New Jersey to manage the Polymer Physics Research Group, working on developing methodology for rheological surface science and electronic products. In 2000, he returned to the UK as a research manager at Merck Chemicals in Southampton, where he was responsible for developing semiconducting polymers for organic, electronic, and solar cell applications. A key aspect of his research was the exploitation of molecular alignment and organization of semiconducting polymers and small molecules in the liquid crystalline phase. At Merck, his group discovered a liquid crystalline thiophene polymer, which subsequently underpinned many research advances in charge transport of organic thin films since its publication in Nature Materials, which garnered the distinction of one of the top 10 most influential papers published in the first 5 years of publication of this journal. In 2007, Professor McCulloch joined the faculty at Imperial College to continue research in organic semiconductor materials. He co-founded the specialty chemical company Flexing, where he is currently the managing director, supplying a range of electronic materials to leading manufacturers across the world. At Imperial, he continued to explore new chemistries for organic solar cells and transistors. Professor McCulloch joined KAUST in 2014 and became director of the KAUST Solar Center in 2016. His work developing new solar cell materials led to the discovery that a ternary materials blend with 2 non-fullerene acceptors could outperform the equivalent binary devices, leading to high power conversion efficiencies that helped towards a resurgence in the field. He continues to expand his application focus for polymer materials to perform at the interface between biology and electronics, demonstrating electron transport in an organic electrochemical transistor operated in an aqueous electrolyte in ambient conditions. This discovery provided the impetus for a new class of polymer-based electrochemical transistor sensors for biological applications and improve the sophistication of bioelectronic devices. Professor McCulloch is among the top 100 most cited chemists in the world. He is Fellow of the Royal Society, Fellow of the Royal Society of Chemistry, and a member of the Advanced Materials Hall of Fame. He received the Royal Society of Chemistry 2020 Interdisciplinary Prize, the 2014 Titan Prize, and the 2009 Creativity in Industry Prize. He was also recognized with the Royal Society Wolfson Merit Award in 2014. The Blaise Pascal Medal is awarded to Professor McCulloch to recognize an outstanding and demonstrated personal contribution to science and technology and the promotion of excellence in research and education.